Now that we're done with the first part of the process, I'm thinking I can actually go get the two output nulls that I have inside here. So I'm gonna delete these two and allow editing of contents, go inside. We don't really need these two. Gonna cut them, Control X, and go outside, Control V, and makes more sense this way. And here I can, again, just save node type, and then match current definition, and it'll be closed. Now, the next step is going to be for us to convert this to an actual height field. And for that, I'm going to only take into account the ground points for now. We'll use the vegetation points to actually generate a mask for scattering the trees or other types of vegetation that you might want to scatter. But for now, we're just going to be working on the ground points. So these are the ground points. Let me just match current definitions. So here we have the ground points and the vegetation points. Like I said, I'm just going to focus on the ground points for now. And the ground points, what I'm going to do is let's start by creating a height field. So I'll create a height field. And the first thing I want to make sure is that this height field has exactly the same size as this. So we'll go over and we'll reference this node and we'll use the same thing, bounding box. From this time, we're going to specify the node exactly. And let's say dot dot slash out ground points dx size, all caps. And we'll copy this and put the same thing here, Control V, but it's going to be the Z size. Okay, and this gives us exactly a height field with exactly the same size as here. If we have a look at this, let's see, we have this size, and it's the one that we have here as well. All's good. Now, the next thing I'm going to do by default, the height field, as you know, has two fields. Okay, we have height and mask. And I'm gonna leave the grid spacing at 2 meters for now. And out of these two, the height field, both of them are actually at 0 right now. We have 0 mask and 0 height. Our lowest height, you remember, was also 0. That's not really all that relevant for now, but so what we're going to do is we'll start by flattening these points all the way down, but in order for them to kind of overlap the height field, but we want to make sure that before we do that, we actually store the original height on each one of the points. So we'll create a point wrangle, PW, here, and let's store the height on a new attribute. So I'll create a float attribute called my height equals my y coordinate of the position vector. Okay, so now I'm storing my height. If we check the attributes of our points, we'll see that we have a new attribute that's actually storing this value, okay, for each point. Next, we're gonna bring them all the way down. So let's say that py is gonna be equal to 0. And that flattens to 0. Now, what we need now is to find a way of, on our height field, go over each voxel of our height field, look for the nearest point coming from here. So let's rename this, so store height and flatten. We're going to look for the nearest point coming from here, and we'll check its value, my height value, and then we'll convert that height value, my height value, to a height value of the height field. So we'll create a height field wrangle, and we'll have first input is going to be the height field, and the second input is going to be those points. And we're going to say that we want to check the height of the nearest point. Let's first check what's the nearest point. Int my reference point, something like that, equals, I'll use the near point function, which only returns one point. And in this case, since I'm not going to be running over, I'm not running this over these points, the first point that's going to be returned is actually the nearest point to the voxel. Okay. So near point coming from input 1 and based on my position, my voxel position. Okay, now that I have my reference point identified, I can say that the height value is going to be equal to the points attribute, point from input 1, and the attribute is my height. That's where I saved the original height of the point, and I want to grab my ref point. That goes over all the points, and as you can see, voila, we have our points converted to the height field. And now we can clearly see all the detail that this satellite data gives us. Quite a good amount of data. Okay, beautiful, beautiful formations, real world formations. Okay, so this concludes the first step of converting this to a height field. So now we already have the height field. We don't have much information. We only have the height, which was the only information that was actually stored on those points. But from here we can find ways of adding a lot more information to this and take this even further. See you on the next lesson.